All right, so today we're going to be talking about the distributive property. So when we hear the word distribution, what do we think of? A few examples we could think of are, oh my goodness, are like passing out papers, or when you get boxes delivered from like Amazon, or even something along the lines of going to lunch and getting your lunch in line. These are all really good examples of when we hear the word distribution. And when we think of that, we need to understand that it means that we're passing it out or taking it over from one place and spreading it across a few other places. So we're going to look at the formal definition of the distributive property. So when we're looking at an example that has something like A, parentheses, B plus C, and then closes parentheses, what that means is we could distribute that A to the B and the C. So what it would look like is A times B plus A times C. Remember, if numbers or letters are touching, that means that they are multiplying. So keep that in mind through this property. We're going to go ahead and look down at our numeric examples. The first one is 3 times 2 plus 5. So we're not going to do the parentheses first like we would in order of operations. What we're going to do is distribute that 3 to the 2 and to the 5. So I'm going to rewrite this as 3 times 2 plus 3 times 5. Once we get here, we can go through solving each piece. 3 times 2 is 6. Bring down my plus sign. 3 times 5 is 15. And then 6 plus 15 equals 21. We're going to do the same thing here with number 2. So we have 4 times the value of 9 minus 7. So we're going to distribute that 4 to both of those values. So we're going to rewrite it as 4 times 9 minus, because there's a minus sign here instead of a plus sign like up top. And then we're going to do 4 times 7. So when we solve this out, 4 times 9 is equal to 36. Bring down your subtraction sign. And 4 times 7 is equal to 28. When we solve this out, 36 minus 28 gives us the answer of 8. So that's how we do it with numbers. As we move up in our math levels, we're going to be seeing more with the algebraic examples. And this is more so how you're going to see it. So we're going to be multiplying that number with a variable value. So in number 1, we have 5 times g minus 9. We're going to distribute that 5 to both of them. So we would write this as 5g. So remember, if there's numbers and variables, they can be touching and not have a sign, and that still means to multiply. Bring down our subtraction sign, and then 5 times 9. I'm just going to simplify this out by rewriting my 5g because I can't do anything with that. And then 5 times 9 is 45. This one we're not going to get an answer to. We just need to simplify it as much as possible. And that's what we got with the 5g minus 45. This number 2 example seems a little bit more, but it's the same exact idea. We're going to take this 3 and distribute it to the 2x squared, to the 4x, and to the minus 1. So 3, I'm going to rewrite this out as 3 times 2x squared. Bring down my plus sign. Then I'm going to distribute the 3 to the 4x. So 3 times 4x. And then I'm going to distribute that 3 with the minus 1. So minus sign and then 3 times 1. I'm going to go through and solve each of these pieces. Again, remember, if there is a variable, you can't combine the numbers and the variables. The variables just stay exactly the same. So really here, what we're going to do is just do 3 times 2, which gives us 6, and bring down the x squared because we don't know what the value of x is. Bring down our plus sign, and we're going to do 3 times 4, which is 12, and bring down the x because we can't do anything with it. And then we're going to bring down our subtraction sign, and 3 times 1 is 3. We can't do anything else with this. We can't combine any of those variables or other values, so that is our answer. 6x squared plus 12x minus 3. There is another way to use a box in order to help do this. So what you would do is you would take what's in your parentheses and put it on top. So I'd put x above one box and 3 above another box. The 4, what I'm going to distribute, is going to be out front. So 4x is just 4x, and then 4 times 3 is 12. I'm going to rewrite this on the line, including the sign that they gave me in the parentheses, so it'd be 4x plus 12. We're going to do the exact same thing here for number 2. We're going to distribute that 3, but instead of doing it like we did in the algebraic examples, we're going to use the box. The 3 goes out in front, and then we have the 2x squared, 4x above this one, and 1. We're going to multiply the numbers together and leave the variables as they are because they cannot change. So 3 times 2 is 6. 3 times 4 for that second box is going to be 12, and bring down your x. And then 3 times 1 is 3. Be careful to pay attention to those signs that are in between when you're rewriting it. So between x squared and x, we're going to have a plus sign. So I'm going to rewrite this as 6x squared plus 12x minus 3. So whichever way you prefer, you can utilize that. You can draw your own boxes or just go through the distribution process, whichever one you like more. So we're going to move down to this application. It's going to give us a real-world example of how this might be used in real life. And then we're going to practice some more on our own. So the application question says, the Hernandez family owns 2 cars. In 2009, they drove the first car 18,000 miles and the second car 16,000 miles. If it costs 65 cents on average per mile to own and operate the vehicle, find the total cost of operating both cars. So in order to solve this one, what we're going to do is we're going to take the information that was important. So we have the first car is 18,000 miles, second car is 16,000 miles, and then this amount of money, which is the cost of operation. That cost applies to both cars. So I would write this as 0.65 because that is it's cents, it's not in dollars. And then we're going to do our parentheses. We would have 18,000 first, and then we're going to add 16,000 because those are the miles that both of the cars have been driven in that first year. So we're going to distribute this 65 cents and multiply it 65 times 18,000, and we're going to multiply it by 16,000. When we do this, I end up with 11,700 as the new value for the first car, and then we're going to add 10,400 for the second car. Now, that's because I did the math here. I'm not going to show you the math on this one. You should know how to multiply by now. So we're going to just go with what we should have. When we combine these two values, we should end up with a total of 22,100. So let's go over to the you do section and go ahead and get started on some of those questions. Again, we're just distributing. We can't solve if there is a variable. So in number 2, number 3, and number 4, we're not going to be able to solve completely to find a single answer. We're going to solve it to simplify. So for number 1, we have 6 times 12 minus 2. So we're going to distribute that 6, to both of those numbers. 6 times 12 minus 6 times 2. 6 times 12 is equal to 72. Bring down our subtraction sign. And then 6 times 2 is 12. When we subtract 12 from 72, we get a total of 60. For number 2, this one has a variable, so we're still going to distribute that 2 to both of the values inside the parentheses. So this would be 2 times 4 plus, because that's our sign, 2 times t, or we could just write it as 2t, because when numbers and variables are next to each other, it means that they're multiplying. The only thing we need to simplify here is the 2 times 4, which is 8. We bring down the plus sign and the 2t. This would be as simplified as we could make this problem. Number 3, we're going to take that 4 and distribute it to the 3g and to the 2. So we would write this as 4 times 3g plus 4 times 2. When you have a variable and a number in front of it, we just take the number and multiply it by what we distributed. So 4 times 3 is 12, and bring down the g, put our plus sign down, and then 4 times 2 is 8. This would be as simplified as we could make this expression. So we're going to do number 4. We're going to distribute this 3 to all 3 of them. So we're going to do 3 times 5x squared minus, because that's our sign, 3 times 4x plus 3 times 1. We're going to combine the numbers here. So 3 times 5 is 15, and bring down your x squared. Your minus sign comes next, and 3 times 4 is 12. Don't forget that x. Bring down our addition sign, and then 3 times 1 is 3. We can't combine anything here, so that is as far as we could go. I hope this makes utilizing the distributive property a lot easier and more understandable for you.